Coming in 2016, Matrices and Systems of Equations from Curves Math. Part the second.
Okay, so now we're going to do Gauss Jordan elimination for the matrices. So all that means is yesterday we put it, remember Gauss elimination or row echelon form, and we put it in the form where our main diagonals were all ones. And we had some number here. Let's make that a 2, 3, 2, and I'm making this up. And then it's equal to 7, 4, 3, and we had zeros down here. So what this tells us is that z equals 3. So now we're going to take this an additional step and make these elements also equivalent to 0 so that it looks like this. 1, 0, 0, 2. Let's say that we end up with 2. 0, 1, 0, 4, 0, 0, 1, 3. So now this tells me that I have solutions, and our solutions are x equals 2, y equals 4, z equals 3. So now we're going to take our matrices and we're going to reduce it just a little bit more so that that way we can actually organize the solution to the system. And here's an example. Okay, so here we took this system, we put it in matrix form, we reduced it to Gaussian elimination or row echelon form, and now we're going to take this matrix and convert it to reduced row echelon form or Gauss Jordan elimination. So the first thing we want to do is we want to get a 0 in this element. So yesterday we were manipulating top rows to get the bottom rows to look how we want them to look with the zeros and the ones. Now we're going to manipulate the bottom rows and work our way up. So if I multiply row 3 by negative 3, then add it to row 2, I will get a 0 where I want it. So negative 3 times row 3 plus row 2 is going to give me the following values. 0 times negative 3 times negative 6. And I'm going to add that to row 2, 0, 1, 3, 5. When we simplify it, we get 0, 1, and 0, negative 1. So now I actually have the solution for y. Okay. So this is what our matrix looks like now. We used, again, row 3. We multiplied it by negative 3. We added it to the old row 2, and we ended up with 0, 1, 0, negative 1. So far we have the solution for y and z. The next thing I want to do is I want to get zeros here. It doesn't matter if you approach this one first or this one first. But again, we're going to use the bottom rows now and manipulate them to introduce the zeros here. So I'm first going to approach this negative 2. You could approach 3. It doesn't matter which one you approach, okay? So in order to change this negative 2 to a 0, I'm going to multiply row 2 by 2 and add it to row 1. So 2 times row 2 plus row 1. So 2 times row 2 is going to be 0, 2, 0, negative 2. I'm adding it to row 1, 1, negative 2, 3, 9. When I simplify, I'm going to get 1, 0, 3, and 7. So I'm almost there. I have a 0 now where I want it. So this is what our matrix looks like so far. Again, we multiplied negative 2 times row 2, added row 1, and this is my new row 1. The last step I need now is to convert this 3 to a 0. And take a look here at this 1. If I multiply this 1 by negative 3 and add it to this 3, then that changes to a 0. And notice that I'm manipulating the rows that already have the zeros, because if I use rows that have numbers, it will change the 0 that I worked so hard to get. So be careful which row you choose. So let's multiply again row 3 by negative 3. And we're going to add that to row 1. And when we do that, we end up with the following. Again, we multiplied row 3 by negative 3, add it to row 1. We end up with 1, 0, 0, 1. This is our resultant matrix. This tells me that x equals 1. This tells me that y equals negative 1, and this tells me that z equals 2. 1, negative 1, 2 is the solution to the system. You can go back to the given, plug it in, and check your work.